my map. We're gonna need this on our hike. Okay, so it's a little more than a hike. Mount Evans is over 14,000 feet high, and today we're scouting a route right to the top for an expedition that the museum is leading. I'm Teal, your guide. I'm from Grand Junction, and I've climbed many 14ers in my life, but Mount Evans has to be my favorite. You'll see why when we get to the top. Down here at the trailhead, conditions seem pretty good. But at the top, conditions will be really a definite startle response. My body reacted in a very specific way to prepare me to deal with a dangerous situation. The story starts in a part of my brain called the hypothalamus. The hypothalamus decides whether I should be scared or not. The hypothalamus sends up.
Wait, Isaac, like.
That's also the sound of my muscles demanding more oxygen.
I'm sitting here.
Follow along here. It's important. Everyone take a deep breath and hold it. Come on, I mean it. Good. Now you have air in your lungs and oxygen too. The oxygen is moving into your blood. The blood is being pumped by your heart to cells throughout your body. And right now, that oxygen is being used to break down glucose from the food you ate earlier into energy that your muscles can use. Okay, you can breathe out now. The process creates some waste too. Carbon dioxide, which you just breathed out, and water, which you sweat and urinate out. Speaking of which, wait right there.
Damn, bitch.
Okay, where was I? The more your muscles are working, the more oxygen they use. You're sitting, I'm hiking. So my muscles are calling out for about 10 times as much oxygen as yours. How does my body keep up? You've probably noticed that when you breathe hard, your heart pounds too. The heart and lungs work as a team. Place your finger inside your sensor again, and we'll get another reading. This time we want the bottom number. That's your pulse, or the number of times your heart beats every minute. Notice how spread out your scores are. This is the opposite from your blood oxygen numbers, which were pretty much all the same. So, while our heart rates and our lungs are all different, something is coordinating our heart and lungs to work together to keep the same level of oxygen. The secret lies in a really old part of the brain called the brainstem. This isn't the part of your brain that makes you smart. It's the part that keeps you alive. The brainstem is connected to almost every part of the body, and it constantly monitors and adjusts breathing and heart rate to maintain homeostasis in your body, no matter what you're doing or where you're going. And I'm going that way, up. Okay, I'm really sweating now. When our muscles move, they make heat, lots of heat, sometimes too much heat. And sweating is one way to get rid of some of it. You're seeing me through an infrared camera that's showing hot and cold areas. The yellow and green areas, like my clothing, appear cold. But the red areas, like my exposed skin, look warm because they're losing heat to the environment. What's harder to see is that just under my skin, my blood vessels have widened to allow more blood to flow to the surface and carry heat out of my body. This is homeostasis at work again, maintaining my body at a constant temperature. Without it, I'd heat up about 1 degree every minute. In 15 minutes, I'd be nearly 114 degrees. So sweating is a good thing. Oh, that's so cold.
Like and subscribe.
Now I have the opposite problem. I'm losing too much heat to the environment. Here, take a look. You can actually see the wet line on my leg. Both areas are losing heat, but the wet part is losing it faster. In fact, if you look at what's happening across the whole body,